Okay, I am now going to do a video lesson on the volume of prisms, cylinders. We're also going to get to pyramids and cones. Alright, so if we think about volume, volume of a solid is really just the number of cubic units that can be contained in its interior. So we measure it in cubic units, meters cubed, feet cubed, units like that. So if we really try to think about it, if you had a rectangular prism like this, and it was 5 units long, and 3 units wide, and 4 units high, and we wanted to know how many of these little unit cubes, one by one by one, will fit in the box, and what the volume of the box is. If we look at it, you can see that the base of the box is 5 units by 3 units. That would mean that we would have down here 5 times 3, or 15 cubes. But we have to do this 3 more times to fill up the whole box, right? Because we have this, and then this, then this, then this. It's 4 units high. And so it contains 4 layers of 15 cubes, and that would give us 16 unit cubes in this rectangular prism. So our conclusion is the box is completely filled by 60 cubes. And since each cube has a volume of just 1 cubic unit, the volume of this box is 60 cubic units. Now, in this example, the area of the base was 15 square units, and we just said we need that 4 times multiplied by the height, and that gave us the volume. So you obviously, when you're calculating volume, aren't always going to be able to put little squares in and little cubes and count it up. This was just a way to conceptually show you what volume is about and why the formula for volume is really just taking the area of the base and multiplying it by its height. And the same method can be used for cylinders as well, where just the volume of a prism is just multiplying the area of the base by the height of that prism. So I also want you to consider this. Let's say I had 2 stacks of paper like this. They both have the exact same number of pieces of paper. The papers are exactly the same size. And let's just say I was a little bit neater with this one. With this one, it kind of got shifted a little bit to the left. This one's an oblique prism, and this one's a right prism. But they have the exact same height. And every cross section parallel to a base is the area of 1 sheet of paper. So these stacks have the exact same volume, and that makes sense to you, doesn't it? It's the same number of pieces of paper. This one just got shifted a little bit. These two have the exact same volume. And what this illustrates is an important principle. That's the Cavalieri principle. This guy's Cavalieri. He was born in 1598, died in 1647. And what he basically said is, if 2 solids have the same height and the same cross-sectional area at every level, then they have the same volume. So you can see that if, even with these being different shapes, as long as this area is equal to this area, which is equal to this area, and their heights are all the same, then these 3 would have the same volume. And that's Cavalieri's principle. So, as we discussed when we were filling up that rectangular prism with cubes, the volume of a prism is really just the area of the base times the height. And that is no different for a cylinder, which, as we discussed, is just a circular prism. It's just we know the area of a base of a circle is pi r squared. So we just write it slightly differently and say it's pi r squared h, but it's really still saying it's the area of the base times the height. So if we wanted to find the volume of this right prism, we know that volume is equal to the area of the base times the height. So in this case, the area of the base is a triangle, so it would be 1/2 base times height, since that's the formula for the area of a triangle. And we know it'd be 1/2 times 3, because that's the base, and 4, that's the height. Be careful with that. And then we realize that that would mean that the area of that triangular base is 6 centimeters squared. And we know that volume is just base times height. We know the height of this is right here because it's the distance between the 2 parallel same-shaped bases. So it's 6 times 2, and we get as our answer that the volume is 12 centimeters cubed, and we would not forget our units. Okay, so what about if we wanted to find the volume of this right cylinder? I'm going to argue it's no different. It's just the area of the base times the height. It's just in this case, the area of the base is pi r squared since the base is circular. All right, so once again, the area of the base is pi r squared. 8 is our radius, so we substitute it in. That gives us 64 pi inches squared for the area. We have to multiply that area of the base times the height, and our height in this case, the distance from base to base, is 6. So that would be 64 pi times 6, or 384 pi inches cubed. If you wanted to do I don't know if I did an approximation here. Oh, I did. If you wanted to do an approximation, it would be 1,206.37 inches cubed. Okay, so we could also use our knowledge of these formulas to solve for x in this case. Oops, sorry about that, guys. There we go. Okay, to solve for x in this case, so in this case, we know that they're telling us the volume is equal to 100, and we don't, and it's a cube, so each of these sides is the same, but we don't know what x is. So the way we would solve this is the volume is just equal to the area of the base times the height. In this case, the area of the base is s squared, the height is s. So it's actually x squared and the height is x, so that's how we get x cubed, and we know that volume's 100. So if we just take the cube root of 100, we get approximately 4.64. So the height, width, and length of this cube is approximately 4.64 feet. Okay, we could do the same thing to solve for x if all we're being told is that this right cylinder has a volume of 4,561 meters cubed. Once again, we know volume is equal to base times height, and in this case we know the base is pi r squared, but we don't know what r is, so we're calling it x, pi x squared, and that's what we substituted here, but we do know the height is 12. So we can just solve for x, and we get that, of course, we would use the positive square root. We don't need the negative square root in this case, and we get x is approximately equal to 11, so the radius of the cylinder is approximately 11 meters. Now, we also can find volumes of pyramids and cones. We just learned that the volume of the prism is just the area of the base times the height, but you can tell from this figure here at the left that there is no way that this pyramid that has the same base as that prism, there's no way it has as much volume as the prism does. So we use a similar formula. It is the area of the base, and we do multiply it by the height, but it's only 1/3 the volume of the prism. So here are our formulas. The volume of a pyramid is 1/3 the product of the area of the base and the height of the pyramid. So it's 1/3 base times height. And if you'll remember back to Cavalieri's principle, if I slice little cross sections through here, that's going to be the same as that one. So the volume formula is true for all pyramids. They don't have to be right pyramids. The height of an oblique pyramid is this height, right? Because we have to get it at a right angle. So its height won't even be inside the pyramid, but it's the length of the perpendicular segment from the vertex to the base. So volume of a cone is really no different. It's 1/3 base times height, but we know that the circular base has a formula of pi r squared. So it's 1/3 pi r squared times the height. So how do we use this? If we want to find the volume of a pyramid that has a regular base, so we know all the sides are 3 centimeters and it has a height of 4. All right, since this base can be divided, as we keep doing, into 6 equilateral triangles, we can use that formula. I don't like how it's written there, square root of 3 over 4 s squared, to find the area of each of these triangles, and we know that each one is 3. So to do that, we have 6 of them, 1, 2, 3, 4, 5, 6. So it's 6 times radical 3 over 4 s squared, which is 6 times radical 3 over 4 3 squared, which gives us 27 rad 3 over 2 centimeters squared for the area of this whole hexagonal base. All right, so then for the pyramid, once again, it's just 1/3 base times height. So we take 1/3. This is the number we just derived on the previous slide. If you'll recall, back here, the height is 4. So that's where we get that 4 from. Add it here, and we get 18 rad 3. So the volume of the pyramid is 18 rad 3 centimeters cubed, or approximately 31.2 cubic centimeters. And if we want to find the volume of a cone, same formula, no difference. It's just to calculate the area of the base. This is going to be pi r squared since it's circular. We once again just use the formula, 1/3 base times height. In this case, pi r squared is the base. The height is here. So this is pi r squared. This is my height. And when I simplify it, I get 907.18 pi millimeters cubed, or if I wanted to simplify for pi, I could get that. And just to show you that we can do this, this was a right circular cone, but there's no reason we can't use the same formula for an oblique circular cone. You just have to make sure that you're being given the height, which in this case has to be the perpendicular distance from this cone, from the vertex down to the base. So it's the same formula that we're using, and you can see that we get 3 pi inches cubed. All right, so be prepared for a potential quick quiz, and we will go over some more exercises to get comfortable with calculating volume.